Good afternoon, my YouTube viewers. Crystal here. What I wanted to do today is I wanted to make another video for you. And this video is still on CatBoost, but it's about what I did when I tried CatBoost on the E.Coli dataset. This E.Coli dataset is very highly class and balanced dataset, and I've made other videos on the E.Coli dataset. And I've made other blog posts on the E.Coli dataset as well, but I wanted to try it again. I wanted to see if I can get CatBoost to improve the performance of the E.Coli dataset. And then in addition to doing that, I tried the Random Forest out as well, so you can compare the performance of E.Coli with Random Forest to see which dataset is better. So without further ado, we'll go ahead and start on the description of the program that I wrote. So I called up the E.Coli dataset, which is very highly class and balanced. And I'll just read the instructions about the dataset. It said the dataset describes the problem of classifying E.Coli proteins using their amino acid sequences in their localization sites. That is, predicting how a problem will bind to a cell based on the chemical composition of the protein before it is folded. The dataset is credited to Kenta Nikai and was developed into its current form by Paul Horton and Kenta Nikai in their 1996 paper titled A Probabilistic Classification System for Predicting the Cellular Localization Sites of Proteins. In it, they achieved a classification accuracy of 81%. And then I'm going to tell you now that I achieved a higher classification accuracy than that. So that's something to look forward to. The dataset is comprised of 336 examples of E.Coli proteins, and each example is described using 7 input variables calculated from the protein's amino acid sequence. And then what it does is it tells you about these amino acid sequences, and it tells you about the classes, but I'm not going to go over that. You can read that yourself because it's a little bit lengthy, and it's something that you can read on your own, because whenever I make my blog post, I'm going to give a link to my GitHub account on the blog post, so you can call it up there. So if you would like to have the code for this, you'll have to read the blog post that I'm going to be making. So the first thing I did was I imported my libraries. I've written my program on Google Colab, which is a free Jupyter notebook, and many of the libraries are already installed on Google Colab. So all I had to do was import them. So I imported Pandas, NumPy, Matplotlib, PyPlot, and Seaborn. And the next thing that I did after I inputted my libraries, I loaded my data set. And so I got this data set from Jason Brownling's site, Mastering Data Science, or Mastering Machine Learning, one of the two. And then we've got the columns as well. We created columns of MCG, GVH, LIP, CHG, AAC, ALM1, ALM2, and the result. So that's just talking about the amino acids and what proportion is in the amino acids. That's all medical biology, chemistry things. Then what I did was I checked the data set for any null values. In this instance, the data set does not have any null values, so we did not have anything that we needed to impute. And then so what we did was we compared the result with the independent variables. So that's some statistics for you if you like statistics. And then what I did was I labeled and coded the last column, because the last column is your target. And it was an object And then so it has to be labeled and coded to make it a numerical value. So train result equals LE fit transform train result. So it has to be converted to a numerical value before you can put it into the model. Then what I did was I made a heat map. So you can see how all of the independent variables relate to the dependent variable, which is your target, which is Y, the result. And what we did was we counted each class. So you can see what you got in each one. And what we got concerned about was class 3, we had 2. In class 2, we had 2. So that's going to be a bit of a problem because we've only got 2 examples of count 3 and count 2. And so that's going to be very, very difficult to find a model that's going to be able to pick up really these two examples. And then I just did the same thing another way, just to give you the percentages so you can see what percentage you have of each class. So 0 is 42%, 1 is 23%, 2 is 1%, 3 is 1%, 4 is 10%, 5 is 6%, 6 is 1%, and 7 is 16%. So I just kept the percentages at an integer for simplicity. So we've got some more statistics that we counted it, so you can count it if you like. So now we have a percentage of the result, so you can look at that if you like. And now we've got a graphical representation of the result. So you can see the graphical representation of the result. You can see this is a very highly imbalanced data set. So this is, a good data set to work on, because if you can solve this problem, you can solve any imbalance problem, hopefully. And then what we've done is we've done a graphical representation of all of the columns, if that's what you're interested in. And now what we've done is we've defined our X and Y variables. So Y is train result because that's your target variable, that's your dependent variable. And X is train dot result X1. So we're going to keep all of the columns in X in train except for the last one. So we've dropped the last column. And so we got a shape of it. So X shape is 335 with 7, and Y shape is 335 with 1. So I'm not sure exactly why that happened, because it says right here that we've only got 335, but I think if you go all the way up to the very top, because I got this from Jason Brownlee's site, it says 336. So Jason Brownlee is saying it's 336. But here we've only got 335. So we've got a missing row somewhere, but I just took it from Jason Brownlee. So if it's missing a row, then Jason Brownlee did something to get rid of one of the rows, because I just took the data set directly off his site. Okay, so after we defined our X and Y variables, now we split the data set. We split X up. So you've got X train, X val, Y train, Y val, and equals train test split, X, Y, random state equals 0, test size equals 50%, stratify equals yes. And I suppose what I could have done is I could have done shuffle. So when I finish this video, I might put it on shuffle and see if that improves my score. And if it improves my score, I'll let you know. So then we put the X train and X val on a scaler, so we scaled it. And then we put it on, we counted everything. So we've got 0 is 71, 1 is 39, 7 is 25, 4 is 18, 5 is 10, 6 is 2, 3 is 1, and 2 is 1. So we've got a representation of all 7 of those examples. So that's good. And so all 7 of the examples are set up. 3 is 1 and 2 is 1. So I guess maybe I don't need to do shuffle. I can try it with shuffle just to see if it improves my accuracy. And we'll give it a go. So then we set our class weights. But in this instance, I didn't actually even use the class weights. But I kept it in there anyway. Okay, and so now we've done a disk plot. We've charted our XY val, so you can see what Y val looks like. You can see it's very highly imbalanced. So now what we had to do is we had to install CatBoost because CatBoost is not installed on Jupyter Notebooks. And because it's not installed on Jupyter Notebooks, we have to install it. And then now what we've done is we have set up our model as being CatBoost. So the loss function is multi-class, and then we have to set up our class weights. So our class weights for 0 is 58, because that's 1 minus 42%. Set to 1 is 0.77, so that's 1 minus 23%. 2 is 0.99, because that's 1 minus 1%. 3 is 0.99, because that's 1 minus 1%. 4 is 0.90, because that's 1 minus 10%. 5 is 0.94, because that's 1 minus 6%. 6 is 0.99, because that's 1 minus 1%. And 7 is 0.84, because that's 1 minus 16%. So I set up my class weights. I set it up for 300 iterations, a depth of 5, random state equals 1, fit X train, Y train, and then we print CT model score X train, Y train. So that's what we did. So we go down here. It's only 300 iterations, I believe. And we got 100% on an X train, Y train. So that was good. And now what we're going to do is we're going to predict on the validation set. And we got 88% on the validation set. And that was higher than the previous video I've made on the subject. We put it on a counter. We've got 0, 1, 6, 3, 4, 11, 5, 2 on our validation set. So let's see what it says. 0, 1, 2, 3, 4, 5, 6. I don't see a 7. Do you see a 7? So I don't see a 7. So it's missing out one of the examples. And you can see when we do our confusion matrix here, it's missing out number 8. You can see that it's missing number 8. So we do a disk plot on it so you can see graphical representation of this data balance. And then we count it all, and you can see it's missing number 7, I believe. 0, 1, 2, 3, 4, 5, 6. It's missing 7. So it's missing the 8th one. So now what we're going to do is we're going to do random forest. We're going to do exactly the same thing, but we're going to use random forest as our model. So the class weight is balanced. Number of estimators is 500. Max depth is 10. Random state is 1. fit X train, Y train. And we got, when we print out the accuracy, we got 100% accuracy when we did that. And we only got 85.71% accuracy. So that's close to 86% accuracy. So we've got 2% less accuracy on Random Forest than we did CatBoost. And so we counted it. So we've got 0, 1, 6, 3, 4, 5, 2. So again, we're missing number 8. And you can see when we do our confusion matrix that we're missing number 8 as well. And then we put it on a graph so you can see how it's graphically represented. And then we count it and you can see that we're actually missing one. So what happened is both of these models didn't pick up one of the ones. But what I'm going to do is when I finish this video, I'm going to put the model on shuffle and see if shuffle helps a bit. So that concludes it for this presentation on what happened when I used CatBoost and Random Forest on E.Coli. It did actually improve the accuracy. I got 88% accuracy on CatBoost and approximately 86% accuracy on Random Forest. So the accuracy was definitely improved, but it needs some work. We need to try to get that extra point in there that we keep missing out. So if you like my video, please like, subscribe, and share. If you like the work I do and want to make a donation, I'll leave my email address for my PayPal account so you can make a donation if you want to, because I get monetized. I don't have enough viewers, and the only way I can make any money on this site is to get monetized. Is to ask for donations. So thank you so much for watching this video. I look forward to making more videos for you.